Now we've just gone through the axisymmetric plume. Let's do some examples of using the axisymmetric plume far field model. Example 1. Determine the mass flow rate of smoke for an axisymmetric plume with the following parameters. Now your fire size is 3 metres by 3 metres, your convective heat output is 4,500 kilowatts, your clear air height is 18 metres. Let's go through this example now. Now we know it's an axisymmetric plume, but not whether or not it's a near field or a far field model. So that's the first thing you need to do. Now the rule is, if the clear air height is greater than the longest dimension of the source, the longest dimension of the fire, multiplied by 5, then it's deemed to be a far field model. If not, it's a near field model. Now in this case, the clear air height is 18 metres. Now 5 times the longest dimension of the source here is 5 times 3 is 15. So in this case, the clear air height is greater than 5 times ds. So this is classified as a far field model. And this is the axisymmetric far field plume model here, where m smoke equals 0.071 times qp to the third times z minus z0 to the 5/3, where m smoke is the mass flow rate of smoke in kilograms a second, qp is your convective heat output in kilowatts, z is your clear air height in metres, and your zo is your virtual source in metres. Now your zo, to determine your zo, which is your virtual source, you use this formula. ZO equals minus 1.02 ds, which is your longest dimension in the source, plus 0.083 times QP, which is your convective heat output in kilowatts, to the power of 2/5. Let's work that out first then. Your ZO, if you'd have put the formula in the formula, your known parameters, you should have got a Z0 of minus 0.66. That's the virtual source. Now you know that, you can put it into the formula, which is here. You'd have got m smoke equals 0.071 times 4,500 to the third times bracket 18 minus, so 2 minuses make a plus, remember that, minus 0.66 to the 5/3. If you'd have put that in, you'd have got a mass flow rate of smoke of 153.88 kilograms a second. That's what you'd have got. Now let's compare this to the SIBSI Guide E model, where ZO is deemed to be 0. Don't forget, SIBSI says Z0, because it's virtually negligible, can be ignored. Let's just have a comparison with the SIBSI Guide when it takes out the ZO. If you'd have put that in, this formula, as you can see here, without the ZO, you'd have got a mass smoke of 144.9 kilograms a second. So if you compare them, you'll see that that's a 6% decrease if you ignore the virtual source. So a 6% decrease. Let's do another example. Example 2. Determine the mass flow rate of smoke for an axisymmetric plume with the following parameters. Your fire size is 3 metres by 4 metres. Your convective heat output is 5,000 kilowatts. And your clear air height is 21 metres. Now again, we know it's an axisymmetric plume, but not whether or not it's a near field or far field model. That's the first thing you've got to establish. And the rule is, if the clear air height is greater than the longest dimension of the source, the longest dimension of fire, multiplied by 5, then it's deemed to be a far field model. If not, it's a near field model. In this case, the clear air height is 21 metres, 5 times the longest dimension of the source, which is 5 times 4 is 20. In this case, the clear air height is greater than 5 times ds, and so it's classified as a far field model. And again, this is the axisymmetric far field model. M smoke equals 0.071 QP to the third times Z minus ZO to the 5/3. And again, we need to work out ZO first, your virtual source, using this formula here. ZO equals minus 1.02 times ds plus 0.083 QP to the 2/5. You'd have put that put the known parameters in there into your ZO. You'd have got a virtual source of ZO of minus 1.58. Now you can put the ZO into the original formula. You'd have got m smoke equals 0.071 times 5,000 to the third times brackets 21 minus 1.58. Don't forget, 2 minuses make a plus. So that's 21 plus 1.58 to the power of 5/3. You'd have got a mass smoke of 219 kilograms a second. Again, let's compare this to the CIBSE guide, which says ZO can be classified as 0. If you'd have put that in the formula without the ZO, you'd have got 194.1 kilogram. Now, if you compare this 219 to 194.1, this is an 11.5% decrease if you ignore it. Now, I don't think that is you can ignore it now. 11.5% decrease is quite significant. So it makes you question whether or not you can classify ZO as being negligible. Now that covers the examples. Now we want you to go through these exercises now yourself to work out this using the Axisymetric plume. So now go through the exercising from 20 onwards.